Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over an example problem of gas stoichiometry. So like every stoichiometry problem that you do, what I always say is the first thing you need to do is whatever unit they give you, you need to get that to moles. So get it to moles, and then once you got that substance that you were given in moles, now you can use the mole ratio in your balanced equation to convert from one thing to the other. That is the main thing you need to do. So get the moles, convert using the mole ratio to convert from one thing to another, and then once you've got moles of your other thing, then you can use your conversion vectors to convert to whatever unit they want you to convert to. Okay. And so in this case, when we're talking about gas stoichiometry, you're going to be using the ideal gas law to convert between, say, liters and moles, right? So you're given liters of a gas and you need to get the moles, or you're given moles of a gas and you need to get the liters, right? But you're going to use the ideal gas law for this, or the equation for this. So let's go ahead and look at this problem. And in this problem, I'm going to show two different ways in which you can solve this equation. So let's do the first way, where you're going to use the ideal gas law equation to find moles or find liters. Okay, so we're given when 4.0 times 10 to the 7 liters of hydrogen gas at 503 degrees Celsius and 155 atmospheres reacts with an excess of nitrogen gas. What is the maximum volume of the NH3 or ammonia gas that can be formed at 20.6 degrees Celsius and 1.007 atmospheres? Okay, so let's begin. So they're giving us a certain volume of hydrogen gas, and we need to get to ammonia gas. So we're going from one substance to another. So the first thing we need to do is get the liters of hydrogen gas to moles. So we're going to need to put that into our ideal gas law equation. So we're going to need to convert 503 degrees Celsius to Kelvin. So we're going to take 503 degrees Celsius. We're going to add 273.15 to that. And that's going to be 776.15 Kelvin. So remember, when we're adding, it's the least number of decimal places we're interested in. So this has the last digit is in the ones place. The last digit here is in the hundredths place. So we're going to go with the ones place. So I'm going to underline our last significant digit. So that's our temperature in Kelvin, and we're given the pressure in atmospheres. So we want to use the volume, pressure, and temperature to convert to moles of hydrogen gas. So that's going to be moles is N. So it's going to be N is equal to PV over RT. So this is going to be equal to our pressure, which is 155. So 155 atmospheres multiplied by the volume, which is the 4.0 times 10 to the 7. So 4.0 times 10 to the 7 liters over R. R is going to be 0.082058, and that's liter atmospheres over Kelvin mole. And then the temperature is 776.15 Kelvin. Remember that the 6 is our last significant digit. So now we can calculate the number of moles. So notice that atmospheres cancels out, liters cancels out, and Kelvin cancels out, leaving us moles. So when we calculate the number of moles, we get 9.7 times 10 to the 7. Let me double check that. So that's right. So where'd it go? 9.7 times 10 to the 7. So this is going to be equal to 9.7 times 10 to the 7 moles of H2 gas. All right, so now that we have our moles, the next thing we want to do is now convert using the equation. So we got moles, here we are. So we were given liters of our gas. We use PV equals nRT to get to moles. Now we use the mole ratio in our balance equation to get moles of the ammonia. So we're going to go ahead and do that. So we're going to take our 9.7 times 10 to the 7 moles of H2, put it over 1. And now we're going to use the mole ratio to convert. So the mole ratio of hydrogen to ammonia. So hydrogen has a 3, this is a 2, so it's 3 to 2. So 3 moles of hydrogen goes on the bottom. So 3 moles H2 goes on the bottom, and 2 moles of NH3 goes on top. So moles of hydrogen cancel out. Now we have moles of NH3. And when we calculate that out, we get 6.5. So that's going to be 6.5 times 10 to the 7 liters of ammonia. So now we're here on our roadmap. We've got moles. And what do they want? They want what is the maximum volume? We're going to assume liters. Since they gave us liters to start with, we'll just go to liters. So now that we have, oops, that should be moles, not liters. Sorry about that. So that would be moles of NH3. Now we're going to use our ideal gas law again to convert to liters. So in this case, liters, what do they give us? So it's 20.6 degrees Celsius. So let's go ahead and erase this so we can give ourselves some room. So now it's 20.6 degrees Celsius plus 273.15. And so that's going to be 293.75 Kelvin. So 293. So now we got our temperature, and then we got our atmospheres, our pressure. So now we want to solve for volume. So now volume is going to be equal to nRT over P from the ideal gas law equation. And so now we're going to plug in our values. We got moles of NH3, so that's going to be 6.5 times 10. Oops, I forgot the 7 here. 7 moles multiplied by R. Again, it's 0.082058. And then again, that's going to be liter atmospheres over Kelvin mole, and that's multiplied by the temperature. Again, the temperature is 293.75. Let me use a different marker here. 273.15. Oh, that's a much better marker. Okay. So now, and then I'm going to divide this by the pressure. So the pressure is 1.007 atmospheres, 1.007 atmospheres. And so we can look, moles are going to cancel out. Look at the units. Atmospheres will cancel out. And then, oops, I forgot Kelvin is here. Kelvin. Kelvin's going to cancel out with Kelvin. And then that's it. We got liters left. So we do our calculation and we get liters. And so we get, what do we get? Oh, oops. So for that should be 293. Sorry about that, caught my mistake. So 293.15. And then when we calculate this out, we get 1.6. So this is going to be equal to 1.6 times 10 to the 9 liters of NH3 gas. So that is the answer. Again, sig figs, we have 2 sig figs here because the least number of sig figs in our measurements is 2 sig figs. And so we have 2 sig figs here. Now that's the first way to do it. I'm going to show you a second way to do it. So the second way to do this problem is to treat the R constant, the ideal gas law constant, as a complex conversion factor. So let's show you how this is done. So we're going to start everything the same way. All the calculations are the same. I'm not going to bother doing the conversions. I'm going to just show you after what the conversions are. So the first thing you're going to do again is you're going to start with the 4.0 times 10 to the 7 liters of H2 gas, right? And then the first thing you're going to do is take the R value and multiply it as a conversion factor. So here we have the units of the R factor, the ideal gas law constant, I should say, not R factor, but the ideal gas law constant is liter atmospheres over mole Kelvin. So here we have liter atmospheres on the top. So we want liter atmospheres on the bottom. So that we're going to put 0.08205.8, and that's going to be liter atmospheres, and then on the top will be Kelvin mole. And these are ones, right? So 1 Kelvin, 1 mole. So now the liters here will cancel out. Now we just need to cancel out the Kelvin and the atmospheres. That's where the other values are going to come in. So we're going to use the temperature and the pressure they give us to multiply and divide to get rid of the units. So since we have Kelvin on top, we're going to put the temperature on the bottom. So when we calculated the temperature, then 776, I'm rounding it this time, so 776 Kelvin goes on the bottom, and then the atmospheres goes on top to cancel out atmospheres here. So we're going to put 155 atmospheres. So then atmospheres cancels out, Kelvin cancels out. Where's Kelvin? I forgot. Kelvin cancels out there. Now we're left with moles. So we got moles of hydrogen. Now we can use our mole ratio to cancel out and convert to moles of, cancel out hydrogen and convert to moles of ammonia. So we're going to use our mole ratio like we did before. So we have moles on top, moles of hydrogen. So we're going to put 3 moles of hydrogen on the bottom. So 3 moles of H2. And then on the top, we're going to put 2 moles of ammonia, 2 moles NH3. Okay. So now moles of hydrogen cancel out. We have moles of NH3. So now we want to go to the volume, which is liters. So now we're going to use the R factor again. So we're gonna, not R factor, sorry. The ideal gas law constant R again. So this is where now we're gonna go down here. And so this time we have moles on the top. So for this time, we're gonna put the 0.082058 on the top with the moles. Oops, not the moles, sorry. The liter atmosphere, and then we're going to put the 1 mole and 1 Kelvin on the bottom. So mole and Kelvin goes on top, or goes on bottom, and liter atmosphere on top. So then now the moles cancel out, and now we're going to need to cancel out Kelvin and atmospheres to get the volume left. And so this time we're going to use these atmosphere and temperature. So again, I calculated already before the temperature. So that's going to be 293.8 on top. So 293.8 Kelvin on top. And then on the bottom will be the atmospheres. That's going to be 1.007 atmospheres. So atmospheres cancels out, Kelvin cancels out. And so now we have liters. That's what we want. So now we're done. And when we do the calculation, we multiply everything on the top right here, divide by everything on the bottom, and we get our answer, and it's the same answer, 1.6 times 10 to the 9. So 1.6 times 10 to the 9 liters of NH3 gas. So once again, we get the same answer, but in a different method. So I hope this was a good video. I hope you like this video. If this was helpful in any way, then please like the video, share it with your friends, hit that like button. Also, subscribe to my channel, please. And when you do, make sure you click the notification bell. And when you do that, make sure that you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section, please. And when you do that, please ask me a question, make a comment. If you have a question or a problem you want me to go over for you, then please let me know. Also, if you have a topic you want me to cover, let me know that as well. Thanks for joining me, and have a great day.